Oh. Okay, so yeah, here's our diagram with the sun here, the Earth here, and the moon at the 2 points on both sides. What they've shown here is the forces, right, on both. You can see when the moon's in between, obviously it's being pulled by both in opposite directions, which is going to reduce the net force, and then on the outside, when it's on the other side of the Earth, it's going to add up. And so they go through that gibberish of all that here. Yeah, pretty much. This was basically just a chapter 3 sort of vector problem, but rewritten in the language of this chapter, right? And they do the ratio. Yeah, here we go. Here's our ratio right here. Let me explode this up a little bit. What the? Get clear. Get clear. Okay. Yeah, so they do the gravity calculations, and then they do this is the then they do the difference, the one with the subtracted, and then they take the ratio of both and get that. So the sun and moon. Oh, okay. Here, this one they did. So this is the one where they're both are being pulled. This is the one where they're fighting. So this first one is the one. Yeah. So this is where the satellite. Satellite is on the outside, and this one is the satellite between, right? Kind of make sense there? Because that's why here they're adding the 2 forces, and then here they're subtracting the 2 forces. Okay, and then here is just the ratio. This part here. It's just the ratio of the 2, and then you get your final answer. So you're just using the universal law of gravitation a couple of times. Questions on that? Yeah.
So we're looking at it from the sun as the origin, or like.
Well, okay. Okay, so putting the sun and the Earth, we're using the sun. Yeah, actually, I think which we're using is the origin. Well, when the satellite's here, and we have this attraction in both ways, Fs and Fe, we're sort of calculating those independent, right? So it's as if for Fs, we're calculating it with the sun as the origin. For Fe, we're calculating it with the Earth as the origin. And then we're just adding those 2 vectors up. That's all we're doing. And then when we go over here, right, we have to calculate a new Fs, right, Fs2, and the Fe, that one should be about the same. Right? The sun one obviously is different because it's from here to there, but then the distance to E is the same. And then of course these 2 we're subtracting, and then these 2 we're adding together. And then I don't remember which one. Did they say which one was supposed to be on top? This was full, right? So that's basically how they had the problem. All right, any questions on that?
In the manual, how they get the difference of that?
Well, let's look. then they would do what, sorry?
Get the difference in the radius.
Difference between, oh, like why are they doing
Yeah,
this?
because it's still counting only 1 point, so why are they?
Okay. Oh, because they're given, are we not given how far this thing is? That's why. So there's, what we do know is the distance between the Earth and the sun. So then they're using the distance to the sun. Now everything's gone, but that's fine. So yeah, here's our sun, here's our Earth. This distance, big R, we know. This distance, little r, we don't know. Right? So then when we calculate the force of the sun on this, whatever, on the satellite, and we do big G, M of the sun. Ah, jeez. I'm just gonna leave that other one as M. Over, and then this should be r squared, right? So it's gonna be r minus little r squared. That's why they get that. Is that working for everybody? See what we're doing there? And then on the other side, Fs is just r plus little r. Is this the, for the, oh, that's the moon, isn't it? Yeah, so I guess we just look it up. Just plug in the numbers. Okay, yeah, so, yeah, it looks like we don't have to solve it out, we just plug in the stuff, so there you go. Which is what they did eventually anyways. Okay, other questions?